Okay, after discussing network segmentation, where we were breaking down a large broadcast domain into smaller broadcast domains so that we have a more efficient network, which is more secure to an extent, where we separate the network according to functions, group, whatever it is. We now look at how do you actually subnet the network. So to give just a brief background of where we're coming from, subnetting. We have a network. Let's say you have a network. You have a network with 1,000 users. Right? This is your network. This is your LAN. We discussed the segmentation from a perspective where it's much complicated to manage a network with 1,000 users. That's a large broadcast domain. Right? We can have segmentation where we now have two different networks, each with 500. That is segmentation. Now, if this was a network 192.168.0.0/16, that is only one network that we have there. And after segmenting, it now means we have two networks. And with two networks, it means we now need two network addresses. The analog I was giving in the previous session, if this is Harare, we have 1,000 users. And this is the address of Harare. This is the network address of Harare. If we now segment, probably we now have a Highfields and a Zeoraseko and a DZ. Two different areas, it will mean two different addresses. So probably we now have to segment, to subnet our address. So we now have a 192.168.0 and a 192.168.2. So from this original address, we can subnet and we can get two new addresses from that original address. That is basically what subnetting is. Networks are most easily subnetted at the octet boundary. You will see as we do our practice, most of the networks that you get, the first network that you get before subnetting, it is at that octet boundary. It's just for practice sake. More complex networks, you get assigned a network address, which is a/13. You can get that. Right, but for practice and for understanding, let's start with octet boundary prefix length, /8, 16, and 24. You definitely be seeing /24 a little bit more than all the others. Notice that using longer prefix lengths decreases the number of hosts per subnet. Right, let's introduce now the number of hosts. How are we calculating this number, the number of hosts? We said that an address, it has a network portion and a host portion. An IP address, 32 bits, 32-bit number, which has a network portion and a host portion. The two are distinguished by the subnet mask. We know that. Now, let's say we have an address 192.168.10.10, and our mask is /24. It means our prefix length is /24. It means our subnet mask is 255.255.255.0. From this information, I can also know that this is our network portion. The network portion of the address does not change. We'll get there. That is our network portion. And this becomes our host portion. What it means, our network portion, we have 24 bits, which are being used as the network, and we have 8 bits, which are being used by the host portion, making a total of 32. Now coming to the number of hosts. The number of hosts, we have a simple formula. 2 to the power of n minus 2, where n is the number of bits. That's how you get the number of hosts. 2 to the power of n minus 2, where n is the number of bits which are being used for the host. How do you know the number of the bits? You know them from the mask. Once you separate the network portion and the host portion, you now know the number of bits for the network. You now know the number of bits for the host, and you can now calculate the number of hosts. Coming to the example that we have here, if you have a /8 prefix length, it means you have 8 bits being used for the network. That means you have 24 bits being used for the host. If you go and calculate 2 to the power of 24 minus 2, this is what you will get. The number of hosts that the network can have. Using longer prefix lengths decreases the number of hosts. Let's get there. If you have a /16, it means you have 16 bits for the network, 16 bits for the host. 2 to the power of 16 minus 2, 65,000 addresses. If you have a /24, 2 to the power of 8 minus 2, 254 addresses. So you see, as the length of the prefix length increases, the number of hosts that the network accommodates decreases. So this also helps, understanding this, it also helps when choosing a subnet to use. So it means if I want to have a network, I have my small network is going to have, let's say, 50 addresses, 50 hosts. I'm going to have maximum of 50 devices in my network, right? As an engineer, as an IT person, if you see yourself using an IP address which has a /8, which has a /16, that does not make sense. Because if you're using that, it will mean you have to accommodate 16 million addresses. Even in terms of the price, you will know, if you approach your service providers, I have a small network, the price that you pay for the network that you have, it will depend on the number of addresses that you are going to get. Like I said, the addresses, I think we gave a hierarchy. They came from IANA to the RIRs to your internet service providers. Where they come from, you have to pay for those addresses. So if you buy this much addresses, when you want to use 50 addresses only, you buy 16 million. It does not make sense. So it's very important to understand that this early. All right, subnetting at the octet boundary. So the first network we are going to subnet as an example, we are going to subnet the 10.0.0.0/8 network. First things first, if I'm given that network, it has a /8, what it means is I have 8 bits being used for the network portion, and I have 24 bits being used for the host portion. That's the first thing. That is the initial network that you get from an ISP. You get this network, then you are tasked to subnet it using /16. What it means is, instead of using /8, we are saying use /16, and that is what subnetting is. How do we understand what subnetting is from that? It means instead of using 24 bits for your host from here, giving you around 16 million addresses, you can use 16 bits for your host, 16 bits for your host, decreasing the number of hosts that you can have, but increasing the number of networks that you can create. I think one thing I missed on explaining when I was explaining the relationship between the number of bits of the network and the number of bits of the host. Right. This is the network portion. This is the host portion. If the number of bits that I have in the network portion. Let me put it this way. All right. It becomes a bit tricky. Yeah. Let me put it this way. Right. I had a /8. Let me use this example. And I was going to the /16. Right. If I go from a /8 to a /16, it means I've borrowed 8 bits from the host originally. I've borrowed 8 bits originally from the host. I need a blank page to work on here. Let me see. Right. Much better. Right. 10.0.0.0/8. This is the original address I have, and I've been asked to subnet using 10.0.0/16. Originally, I have 8 bits network portion. I have 24 bits host portion. It means I have around 16 million addresses for my host. If I go to the subnetting, it will mean I now have 16 bits network, 16 bits hosts. It will also mean approximately 65,000 hosts that I can create. Right, me moving from /8 to /16, what it means I've borrowed 8 bits from the host portion. Initially, I had 24. And if I borrow 8, it means I'm left with 16. The number of bits that I borrow from the host portion, they will help me in creating the number of subnets that I need. So if I borrow 8, 2 to the power of n, number of networks or subnets that I can create. 2 to the power of n minus 2, number of host addresses that I can create. Right. This n represents the number of bits borrowed from the host. This n represents the number of bits left for the host. So in this case, you can say this n is equals to 8 because that's the number of bits that I've borrowed. And if we have 2 to the power of 8, 2 to the power of 8, it should be 256. It means I can create 256 networks, subnets, from the 8 borrowed bits. This is from this side of my address. Right, let's go to the hosts. I'm left with 16 bits for my host. It means I can still create 65,000 hosts from those 16 bits. So two things that I've explained here. Borrowed bits, 2 to the power of n is equals to number of subnets that you can create. Hosts, 2 to the power of n minus 2, number of addresses you can create. So they are borrowed bits. When we moved from /8 to /16, what it means, here I had these are my network portion. And for my host portion, initially I was at /24, bringing a total of 32. After I had a /16. So if I borrow 8 from this 24, it will mean my network will now go to a /16. If I borrow 8 from 24, it means I'm left with 16 for the host. 2 to the power of 16 minus 2, 65,000 host addresses. 2 to the power of 8, 256 networks that I can create. Let's end it there. We'll probably understand with more examples. All right. So here we are using this example, moving from /8 to /16. That's the first example. This table right here. And you see, we are going to create 256 subnets. Let's read into the table. 256 subnets that we can create. And each of those subnets is going to have 65,534 addresses. If you multiply 256 multiply by 65,000, let's just say 65K. This number should be very close to 16 million. Why? Because initially we had one network, this one, with 16 million users, 16 million addresses. Then we said, let's borrow bits. When we borrowed bits, the number of users decreased from 60 million to 65,000. When we borrowed the bits, decreasing the number of users, we increased the number of networks that we can have. So we now have 256 networks instead of one, but the size, the addresses that we can have, it has decreased. So if you do the math, let me try to do it now. If you do the math, let me say 256 times 65,000. Let me see, just to be sure. 256 multiplied by 65,000. I'm getting 16.6 million. So it's very close. We just lost a few numbers there. 16.6 million. So it makes sense. This is what subnetting is. Taking one big network. In our case, the big network is this one. One big network, we break it down into 256 networks, but those 256 networks, they now have less number of host addresses. They now have 65,000. So what are the networks that we have? This is the first network that we have, /16. The second one, 10.1.00. This is the third one, fourth one, fifth, sixth, up until we get to the 255th network, making a total of 256 networks. So that is what subnetting is. The same thing can be done with a /24. Let's use the /24. We are moving from 10.0.0.0/8 to 10.0.0.0/24. If we are moving, it means initially the network. Initially, our network, it has 8 bits. Initially, our network, it has 8 bits being used for the host. Then we have, for the host addresses, we have 24 initially. Right. After borrowing, we borrow 16 from our host. That means we now have 24 bits being used for the host, and we have 8 bits left being used, 24 bits being used for the network, and we now have 8 bits being used for the host. We've borrowed how many? We've borrowed 16 from this initial network. We had a /8, we borrowed 16, we are now at /24. So it means 2 to the power of 16 is the number of networks we can create. Number of networks or subnets that we can create. It means 2 to the power of 8 minus 2 is the number of addresses, host addresses that we can have. That's where we are getting these numbers. 2 to the power of 16, we can create 65,000 possible subnets. We can create 65,000 networks. And each network is going to have a maximum of 254 addresses, 2 to the power of 8 minus 2. You can see here, this becomes the first network, network number 1, network number 2, 3, 4, up until we get to 65,000 networks. We'll get to discuss the range soon after. Let me try to find an example that we can discuss what are the range of addresses that we are going to use. All right, let me put it this way. Let's use 10.0.0.0/8 and we move to a /16. So initially we had 10, right? 1, 2, 3, 4, 5, 6, 7, 8 dot 1, 2, 3, 4, 5, 6, 7, 8 dot 1, 2, 3, 4, 5, 6, 7, 8. Right. So this is in decimal, and I've just made these numbers as binary. Those are zeros. So this is the initial thing that we had. I want to show you how subnetting works. If we move to a /16, it means I'm going to take all these bits, 8 plus 8, this becomes the network portion. Initially, the network portion was just this one. And if you borrow 8, that becomes the network portion. This becomes the host portion. The first IP address that we can have from this network is 10. The first IP address, we just change from this 0, it becomes a 1. That's the first IP address that you can assign. And in decimal, that IP address is 10.0.0.1. That is the first IP address of the network. Which network are we talking of? The first network is a 10.0, where all these borrowed bits are all zeros. That's the first network. The second network that we are going to have, you see this 0 changes to a 1. That's the second network. It means my second network is going to be 10.1.0.0. My third network becomes 1, 0, which becomes 10.2.0.0. So when all these bits change up until we have 1, 1, 1, 1, 1, 1, 1, that's how the number of networks increase. So the number of networks will increase like this, 10.3.0.0, up until we get to 10.255.255, which were the numbers we were seeing in the table. I'll go back to the table. This is how the network increase. This is the network side. On the host side, these are the numbers that increase. So we start with 1, we go to 2, this is 2 in binary. We go to 3, this is 3 in binary. So on the host portion, they will increase like this. The first network was 10.0. That was the first network. The second address, 10.0.0.2. 10.0.0.3. It increases. When we get to all ones here, when all these zeros are ones, 1, 2, 3, 4, 5, 6, 7, 8, it means our address will be 10.0.0.0.2.555. And once you are done with all these ones, the ones here start changing, the zeros start changing. If this 0 changes to 1, our address will become 10.0.1.2.555. So after this address, we get this one. Then they start increasing from 2, 255, 3, 255, 4, up until we get all ones. When we get all ones right here, 1, 2, 3, 4, 5, 6, 7, 8. It will mean we have a 2.0.255.255. And that's where we are getting the range of addresses that we can use. So if you look at the table, this is where these addresses are coming from, right? These addresses, the range from .1 to .254. The last address is 255, where we have all ones. When we have all ones on our host portion, it's now called a broadcast address. So if you take that same logic, unfortunately, we started with a very large network. When we deal with /24s, probably the next example we'll do, it will be much easier understanding how we subnet. But how we subnet, if you understand how to deal with the bits, like I was dealing with the bits, it becomes easier subnetting. Let's have a /24. This is one is much easier to subnet. /24 table to see 6 ways to subnet a /24 network. Right. This is a /24 network. What a /24 network means, we have 24 bits for the network side. We have 8 bits for the host side. 8 bits means maximum 100 and 256 addresses. Right. If we borrow 1 bit, from these 8 bits, my prefix length changes from 24 to 25. I had 24 on the network. I've borrowed 1 from the host. I now have 25. If I now have 25, what does it mean? This is the borrowed bit, by the way. So these were the 24, the original, /24. Then I borrowed this one here. I now have 25. If I've borrowed 1, it means I have 2 to the power of n, which is 2 to the power of 1. I have 2 networks that I can create from that one. 2 networks. Then I'm left with 7. I've borrowed 1. I'm left with 7 bits. And if I say 2 to the power of 7 minus 2, I'll get 126 hosts. Of the 2 networks that I've created here, it means each we have 126, 126, giving you a total of 252 plus, when we given our formula, we said 2 to the power of n minus 2. So plus 4, you get 256, which is the original /24 number of addresses. If I borrow 2 bits, from the host portion, it will mean I will have /24 plus 2, which is a /26. 2 to the power of 2, 4 bits. I've borrowed 2 bits. I'm left with 6. 2 to the power of 6 minus 2, it will give me 62. The same thing. If I borrow 3, I get a /27. If I borrow 4, if I borrow 5, if I borrow 6. So the whole logic of subnetting goes on borrowing bits. Right, let me continue with another session. I can see my time is running up. I have less than 1 minute. Definitely another session, which is the last one, coming after this one.